Okay, a bit of introduction on the coordinate, why we have a graph paper, why the equation suddenly become a line you can draw on the graph paper, and why sometimes we call it an equation, sometimes we call it a function. Okay, because this part was supposed to be, you're supposed to learn in Sec 2, but it may be a bit confusing at that time. Okay, so for the coordinate, the x and the y, all this, let us start with something that you all should know, a number line. So if I have a number line, this number line only is along the horizontal, then we only care about whether how left and how right. Then in mathematics, we usually go to the right hand side. When we go towards the right hand side, it is increasing. So we say this side is the positive, meaning if I have a 0 here, every time I move to the right, the number become increasing, bigger and bigger. So from 0, I move one step, become 1. Move another step, become 2. Move another step, become 3. Move another step, become 4. Then similarly, if I go towards the negative side, this side, means it gets smaller and smaller. So from the center, from the 0 or the 0, then when I move left hand side, it is in the negative direction. So it becomes smaller, it becomes more negative. So if I move one step, it is negative 1. When I move another step, become more negative, become negative 2. The number becomes smaller and smaller. Okay, so on a number line, all my number, all these negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, all this number is just telling me how right and how left. Okay, then when we put another number line in a totally not related direction, this one is left and right. If I add another number line, let's say I add it at the origin here, then it goes in the vertical direction. Then this is also a number line. Then I also put the center here, which is 0. Then in mathematics, or usually when we go higher, we take it as positive. We take it as moving upward is positive, moving downward is negative. So from the 0, when I go up one step, become 1. Go up higher, become 2. Go up higher, become 3. Go up higher, become 4. Go down is negative direction, so become smaller, negative 1, negative 2, negative 3, negative 4. Smaller and smaller as we go downwards. So one of the horizontal line, the number there only care about right and left. The vertical one only care about up and down. How much I go up, how much I go down. Okay, now we put these two lines together, we have formed a space or area. This whole area on the paper become an area. Then we having this area here, we can then specify every point on the area. Where is each point? Where is each point? Okay, by that I mean if I want to specify this point over here, this point A. This point A can be found here by moving 1, 2, 3, 3 units or 3 spaces to the right. Then I move up 1, 2, 3, 4. Move up 4 spaces in the up and down direction. Then to specify this point, I can use the coordinate. So this is where your coordinate come about. And coordinate, we always say right and left first. How left, how right. So that's why the first one is always x, then followed by a comma, followed by the y. How high or how low. So this point A here is 3 units to the right, positive 3. So we write positive 3, comma by how much it moved up and down. So it moved up by 4. So I put the 4 here. So when I tell people 3, 4 is the coordinate, everyone know out of this space is move 3 steps to the right, move 4 steps up. That's why we come to this point, which is A. So every point on this coordinate can be specified by a coordinate. Every point can be specified by a coordinate. Then we can call this horizontal the x-axis, the vertical is the y-axis. So x describes left and right, y describes up and down. Okay, can. Then out of this whole space, then I start to go on to how this relate to equations, all these. So out of this space, let's take a look. If I am telling people this is y, this is x. If I'm telling people I want all the points that follows or that goes by y equals to 1. This equation here, this y equals to 1 is telling people the y is always 1. Don't care what the rest of the world is happening. I don't care what is the value of x. I don't care what is the value of maybe z, abc. I don't care anything. Y is always the same as 1. Meaning, if I want to specify this onto this coordinate or onto this space, y is always equals to 1, no matter what. Meaning, y is 1 means that it is one step above 0. So if I look at here, this specific point here, this point is 1 above 0. So it is y equals to 1. Okay? If I look at this point over here, it is also 1 in the up-down direction. It is also one step higher than 0. So the y is also 1 here. The y is also 1 here. The y is also 1 here. All these points may have different coordinate. So this one, the x is 3, the y is 1. This one here, the x is 2, the y is 1. This one here, the x is 1, the y is 1. This one here, the x, no left and right. So the x is 0, the y is 1. It can also go in the negative direction. Negative 1, 1. Negative 2, 1. So all these points, they are all y equals to 1. Can there be in between? Or in between of in between? All these points in between also will have y equals to 1. That's why end up, if I join all these points together, all these points along this line, they all have y equals to 1. Which is why this line itself, we can call it y equals to 1. Which is also why your horizontal line has this equation. Okay? So if you understand this, then let's say I have another equation. Let's say I have the equation y equals to negative 3. Meaning, I want to go to all the points that y has the value negative 3. And y is only up and down. So every point that is go downwards by 3, meaning all these, they will all have y equals to negative 3. Meaning, this red line over here is my y equals to negative 3. Okay? Then by the same understanding, this time round if I tell you x is equals to negative 2, can I go somewhere to find out where is this x equals to negative 2? Y is up down, x is left right. So this time round if x equals to negative 2, I only care about how left and how right. Meaning, this point over here, when I go left 2 unit, this x equals to negative 2. This point is x equals to negative 2. This point is x equals to negative 2. This point is x equals to negative 2, negative 2, negative 2, negative 2. That is why x equals to negative 2 will give me a vertical line. Okay? So this is why your equations of straight line, your y equals to mx plus c, then you have special case. Vertical line is x equals to something. Horizontal line is y equals to something. Just strictly a number already. They don't have x and y inside the same equation. Okay. Then let us go to a bit. Now we link y and x together. Using still the coordinate. Having all your points. Let's say I have a very simple equation. Y equals to x. where are all the points that y equals to x? Then is you can start to look at, or we can start to try, because when we have a relationship, an equation, how y is linked to x, then every time I change x, y will change. Every time x become a different number, y will also become a number. So this equation itself actually is a relationship between these two, y and x, the vertical and the horizontal. Okay, so when you are asked to plot graph, it is common that we give a table like that. This table, how we read is how x change with y. So when x is, let's say, when x is 0, we read here, x horizontally, you see, when x is 0, when you go down, what is the corresponding y? Then y is same as x, so if x is 0, y equals to 0. If x equals to 1, y also equals to 1. If x equals to negative 1, y also equals to negative 1. X equals negative 2, y also equals negative 2. 2 also 2. Okay, this table is also the relationship between the two different values. So if we go now, every time x equals to 0, y equals to 0. That gives us a coordinate, that gives us a point. The point is here, 0, 0. Then let's say when x equals to 1, y equals to 1, then I will go right 1 unit, go up 1 unit. So this is the point 1, 1. Go right 2 unit, go up 2 unit. This is the point 2, 2. Go negative x, negative 1, go to the left 1 unit, then go down 1 unit. Negative 1, negative 1. This is the point negative 1, negative 1. When I have negative 2, negative 2, this is the point negative 2, negative 2. So it is also not just this specific point, it can be in between. If positive 1.5, positive 1.5, positive 0.5, positive 0.5, positive 0.25, positive 0.25. So end up, if I join all these lines, all these points together, it will form one straight line. Then I can call this straight line also y equals to x. That is why an equation or a relationship between the two values, they will give us a line that we can draw onto the coordinate, onto the graph. Okay, then of course this equation can become a bit more complicated, can have more things inside. For example, if I change this equation from y equals to x into y equals to 2x, then this time round, y is 2 times of x. Meaning, if I still have this grid, when x equals to 0, y is still equals to 0. Y is 2 times of 0, still 0. When x equals to 1, y is 2 times of 1, so 2. X equals to negative 1 times 2 become negative 2. X equals to 2 times 2 becomes 4. Negative 2, negative 4. So this time round, when I move 1 unit to the right 1, then my y will go up by 2 units. If you look at this grid over here, 1, 2. So 1, 2. 0, 0. Negative 1, negative 2. So this time it is still a straight line, but it will now become steeper because my y is a multiple of the x already. That's why it goes up faster. Okay, then it can also move in another different way. Let's say I have y equals to x plus 1. Then this time round, every of my y is always 1 bigger than my x. So when my x is 0, my y is 0 plus 1, so already 1. When my x is 1, y is 2. When my x is 2, y is 3. It is always one step higher. Okay, so this time round my graph, if I go and plot, it will be x equals to 0. The left and right is 0, but it will go up one space. 0, 1 is here. Then 1, 2. So when I'm at 1, it is at 2. When it is at negative 1, it is at 0. The high and low is at 0. Left and right is -1, up and down is 0, so it is here. -1, 0. When it is -2, it is -1. Okay, so we will have one line here. This time it looks like this. It is just the y equals to x bring higher by one step, because it is always higher by one step. So different equations, okay, different equations will give us a different look or a different line onto the graph. Okay, then you all have also learned this other graph before. When you are learning your quadratic, you have your y equals to x squared. Okay, this time round it is also still a relationship between y and x, and my y and x will keep changing with each other. So when my x is 0, y is 0 squared, so it is also 0. When my x is 1, y is being squared, 1 squared is also 1. When my y is 2, my x is 2, 2 squared is 4. 3 squared is 9. Then if I go negative direction, -1. When I square -1, -1 multiply -1, negative times negative become positive, so become still +1. -2, same idea, it will still be +4. Okay, so which is why when we go towards the right, when I look at the x, it goes towards the right. X increase by one step, increase by one step, increase by one step. But when my y increase, it increase by one step, increase by 3 steps, increase by 5 steps, because it is being squared. So it goes up faster than my y, by my x. That's why when I move one step towards the right, it moves a bit, but when I move a bit more, it will go up by a lot more. 4 already. It will go up a lot more, go to 9 already. And when I go to the left, when my x go towards the left, negative, the y still go upwards because it's positive. Okay, that's why your y equals to x squared looks like this. Okay, then the changes in your equation. So right now we have y equals to x squared. If we have y equals to x squared plus 1, then it, okay, use different color to see clearer. Okay, if I have y equals to x squared plus 1, then every time x squared already is still plus 1. So this time round my y equals to x squared plus 1 will go a bit higher. Then because this is an x squared equation, so you can have also variation become having x squared, then got some x inside, then got number inside. It becomes a bit more complicated. Then it will shift your center around, meaning your graph may not pass through the origin anymore. It may be higher, then it may curve differently. It will move the graph in a different way. If the number 2 can change, the number 3 can change, the number 1 here can change. It can be positive, negative, and then it will affect where your graph goes. Okay, then why do we call all these equation functions? Is because now we change a name, because we want you to use it to signify like the y change with the x. Meaning when I have some equations, let's say 2x squared plus 3x plus or minus 3, something like that. This, I view this x as my input, then I view this y as my output. Meaning I change my x. When my x change, it will lead to a change in my y. My y also will follow, will change. Okay, that is the, then we give it this changing of this value with each other, we give it a name, we call it a function. Okay, there are some rules and restrictions, but it is not necessary to remember, so we will skip that first. Next time if you need, then you learn. Okay, so we call this a function of x, how the y change with the x, that's why you call it a function. So following this, you all will be learning different kind of equation and how it looks like. So to give an introduction, let's say I have this one, then if I have y equals to x cubed is x times x times x. So just by, we don't need to really go and plot out all the numbers, but if you think y equals to x cubed, x times x times x, if my x become bigger, will my y become bigger? And is it by the same rate? For example, if x is at first is 0, 0, 0, so x is 0, then 0 times 0 times 0, your y will also be 0. But when my x goes to 2, then my y is 2 times 2 times 2, become 8 already. So my x increased by 2, but my y increased by multiplying it itself so many times, so it increased even faster. Okay, so you can imagine if y equals to x squared, my curves up a bit. Then if y equals to x cubed, means my curve will be curving up even faster. Okay, because the increment is multiplied, is by itself. Okay, so you can imagine when my x become bigger, moving to the right direction, my y will go up even higher, even faster. Okay, then at the same time, when my x goes smaller, become negative, if my x go to -2, then my y is -2 times -2 times -2. When I have -2 times -2, the first two, they will multiply each other, become positive. Then they become positive 4 already, then they multiply a -2, positive times negative will be -8. So this time round, my y is no longer always going upward. When my x go negative, my y will go negative, but it will also go negative very fast. So by that understanding, we can know that this graph is going to turn downward like that. Okay, so your y equals to x cubed looks like that. So this is how the equation and the graph and the coordinate all work together. Okay, so this is an introduction. Next week, when we go to your Sec 3 chapter 7, we will look at more equations, more functions, and see how they look like on the graph.